Look at these macrophages, efficiently stitching together two endothelial sprouts, which will later mature into a new blood vessel. Sprouting angiogenesis is the growth of new blood vessels in areas where the cell population is dense and these cells are starving of oxygen and nutrients. The cells at these highly populated areas will pump out a growth factor called VEGF, which stands for Vascular Endothelial Growth Factor, to draw the surrounding pre-existing blood vessels made of endothelial cells to sprout. The macrophages will then latch onto these endothelial sprouts to fuse them together. This is called vascular anastomosis, and it happens quite a lot during fetal development. After birth, macrophages will do this in two other settings, one good, one bad. The good one is in wound healing. The first thing that happens after a puncture wound is the immediate swarming of neutrophils to the damaged area. This is followed by the inflow of macrophages from blood circulation for the next several hours to days. Around this time, the cells in the local area will also be producing VEGF to stimulate endothelial sprouting and more macrophage recruitment. As the macrophages start latching onto these endothelial sprouts, they will kick the neutrophils off, especially if the wound is clean and not infected. The neutrophils will start to disappear from the area, and the macrophages will continue to change the general local environment toward an anti-inflammatory state for better building and healing of the tissue. This process is super important and really beneficial to us when we're healing from an injury, but there are types of wounds that do not heal. Those would be tumors. In tumors, macrophages help tumors grow and cancer cells to metastasize by nurturing the growth of new blood vessels to feed the tumor, and which would then also provide a conduit for the cancer cells to leave the tumor and spread to other parts of the body. Designing therapies against these tumor-associated macrophages is currently a very active field in immuno-oncology. Tumors as wounds that do not heal has been a concept that's been around for the past 4 decades. It still astounds me that the same process that is so fundamentally important and beneficial for us to stay alive, like being born and healing from injuries, could also cause such devastation as cancer. I guess it really goes to show that the when and where a biological process occurs is just as important as the fact that it does occur. And all that together determines whether or not something is ultimately good or bad for us. So if you want to learn another instance where macrophages betray us and get on the side of cancer, check out this video.